Hey there and welcome to class. So today we are going to talk about steering systems. I think it's safe to say we all know the purpose of a steering system, right? To turn the wheels for directional control. Now how we do that is a whole nother question. Let's start with at its basis, if we're talking the most basic steering system or vehicle that we could talk about, that would be a manual steering system, meaning you don't have power steering. We'll talk about those components later. If we're talking just a base steering system, we've got three major subsystems that are going to have components in them. The first one's going to be the steering column. So your steering column, meaning what's going to attach your steering wheel to the next component, which is our steering gear. Now your steering gear can be a different design from vehicle to vehicle. Most manufacturers these days are going to use a rack and pinion for their steering gear. We need some sort of gear that's going to transfer this motion, your rotary motion, into a sweeping or angular motion, and that's going to be your steering gear. Like I said, usually rack and pinion is what's used today, but a lot of vehicles, a lot of trucks, Chevy really only sort of recently went to a rack and pinion. For the longest time they used a steering gear box, not to be confused with a steering gear. A steering gear is whatever you're using to change the rotary motion to an angular or sweeping motion. Now that can, like I said, can be a rack and pinion or a gear box. And we'll get into those in a moment here. And then lastly, some sort of linkage that's going to go from our steering gear to our steering knuckles so we can actually make the change from our steering wheel to the wheels and have our wheels sweep from right to left, whichever direction you so choose. So let's start at the steering column. Your steering column, like I said, is connected to your steering wheel. So when you go to turn your steering wheel, you are going to turn a shaft. Now there's a number of components in here. We won't break it down too crazy. Like I said, this is an automotive principles class, so we're just going to sort of keep it basic, but in a suspension class, you will get a lot deeper into steering columns. It's important to know that any and all modern steering columns, so the column or the shaft that's going to go from your steering wheel down to the steering gear, is going to be collapsible. In the event of an accident, you don't want to be impaled by your steering column, which has happened plenty of times with older vehicles. It's how, I actually think that might be how James Dean died, but I can't remember, so don't quote me on it. But lots of people died because they were impaled by their steering column. So to keep that from happening when you get into a really gnarly accident, they make the steering column collapsible. So in the event of a really hard impact, the column is actually going to collapse onto itself. You can't ever reset it. They are permanently collapsed if that ever happens. But hey, you're alive. So there's a give and take there. Now, with your steering column, if it is really most new steering columns, even baseline ones, are still have tilt wheel. Older steering columns may not have tilt wheel, meaning you have adjustment to change the angle of your steering wheel. If you want to drive like a bus driver, or if you want the steering wheel as far down as possible. I'm a short person, so all the vehicles I drive, the steering wheel is pretty much as far down as possible. But really fancy columns may have a telescoping feature, meaning you can actually change the steering wheel depth to get it closer to you or further away. So if you're a really large person or taller person versus a really short person, you need to get closer to the pedals. Maybe you don't want to be right up on the steering wheel, so you might be able to telescope it so it's further away. Just so you know, it's really not safe for you to be driving all up on the steering wheel. If you get into an accident, there's a pretty nice airbag that's going to come at you, and if you're that close to it, it's not going to feel good. So you may have tilt or telescoping features. Now to the steering gear box. This is an older design. Less and less vehicles use a steering gear box these days. From your steering column. So when I make the rotary change or angle in my steering wheel, so I turn my steering wheel, what is happening is my column turns in that same motion. Now what we need to do is change this motion into a sweeping or angular motion, and that's what our steering gearbox is going to do. So the steering gearbox has one of two things. or one of two designs. It's going to either be what we call a recirculating ball design. So what you're going to do is you're moving this steering shaft, which has a sort of spiral design on it, and it's going to have these little ball bearings. And as you turn it, there is what you can almost call a nut. They're calling it a ball nut rack on here. So there's a ball bearing in there. And when you turn the steering wheel, this is going to actually move, kind of like a nut on a bolt, up or down on that steering gear. Now what that's going to do is it's going to mesh. That nut has a couple of teeth that are going to mesh onto what you call your sector gear. And that sector gear is going to change in angle. And this is probably not the best angle to look at it, but it's going to change this motion to this motion. And that's how your recirculating ball works. And now the next design is going to be a worm and roller. And a worm and roller has a spiral gear that is called a worm gear. And as we turn it, it's going to turn or change your roller gear. And that, again, is going to take this motion into this motion. This gearbox can be manual or power steering. We'll talk a little bit more about power steering in a moment. This is just the manual design without any help. Now, with a steering gearbox, you're going to need some linkages to attach essentially from either the roller gear or the sector gear that's trying to go this way, right? So from my steering gear box, I'm going to have some sort of set of linkage. Now, a gearbox design requires a lot more linkages, all kinds of connections to go out to our wheel hubs or our steering knuckles. And this is just a common design. There is more than just this one, but a common one that uses a steering gearbox is going to be a parallelogram type linkage. So what we're missing here is our gearbox. Our steering gearbox would sit right here. And what it's going to do is it's going to turn like I said, either the sector gear or a roller gear. And it's going to take this, what we call a pitman arm, and it's going to pretty much turn that arm to do this. Well, I need to move that out to my wheels. So what we did is we attached to that pitman arm that's doing this motion and attached what we call a center link, also known as a drag link. Because we do want to transfer this motion, now the drag link or center link is going to be moving back and forth. And so it's not flopping around here on the other end. We have another arm that's attached to the frame called an idler arm. So now I've got a pitman arm and an idler arm, and in the center here I've got this drag link. So now I've got this type of motion. I still need to attach it to my steering knuckle. So in yellow here, we've got our tie rods. We've got inner tie rods and we have outer tie rods. And as this center link goes back and forth, my tie rod on each end is going to attach to the center link and to our steering knuckle, which in turn is going to have this sort of motion. And this sort of motion is going to push or pull the steering knuckle to make our wheels do something like this. And that's how a parallelogram steering system works. Now here's why we got rid of it, and a lot of manufacturers don't use it anymore, is because I've got 1, 2, 3, 4, 5, 6 wearable joints. And those wearable joints over time are going to create problems when they wear out, and looseness in the steering, and it's going to be more potential for problems. And so this design, it works just fine, but the problem is there's too many points of wear. And so eventually you are going to have a steering system that you can move the steering wheel and nothing happens at the wheels because there's so much looseness in some of these joints here. And you can usually pinpoint the looseness or the loose joint by doing a dry park test. So it requires 2 people. One person's going to be inside the vehicle, sort of moving the steering wheel back and forth. You're not trying to move the actual wheels. You're just trying to turn the steering wheel in one direction until the wheels are about to move, and then back in the other direction until the wheels are about to move but don't really move. So you end up turning the steering wheel back and forth like this, and while the wheels aren't doing anything, the second person is going to hop underneath the car. This has to be on the ground, by the way. It can't be in the air because we need weight on the vehicle's wheels. And the person underneath the car is going to look at each one of these joints. And so if I can see that my pitman arm is moving, but my center link isn't, then I know that this is the worn joint. If I can see that my center link is moving, but my tie rod arms are not, I know that the inner tie rods there are going to be the wearable or the worn out component. So there's ways to check where that looseness is when it does happen. Here's another example, and in fact this is actually a better picture in your canvas because this is if we're sitting on top of the vehicle from the driver's side. Here's our steering gearbox, right? So this is your recirculating ball, and as you turn your shaft there, this is our sector shaft that's going to move, and it's going to turn our pitman arm in one direction or another. And here's our idler arm, here's our track rod. There's so many terms. The center link can also be called a center link, a drag link, or a track rod, by the way. Many names. And then we've got our tie rods on each end as well. These tie rods, the lengths are adjustable to help with your wheel alignment when it does get out of alignment. We'll talk about that in the next video. But this is just sort of another picture to help you better understand a parallelogram steering linkage. Now another design would be your rack and pinion. The rack and pinion is a much simpler design in that it's pretty compact. There is less linkages. It's pretty much all steering gear and very little linkage because again we want to reduce the wear components, right? If I don't have so many places that can wear, we're going to keep our steering nice and tight. Now the main components in a rack and pinion design is going to be a pinion and a rack. And those are pretty much just two gears, a pinion gear and a rack gear. And then from there, we've got tie rods, kind of like the parallelogram. So I've got to have something that connects my steering gear to our steering knuckles, and those are going to be our tie rods, our inner tie rods and our outer tie rods. So I've got some better pictures here probably to show you. Here is a sort of blown up picture. You guys might identify or recognize this suspension design, right? This is McPherson Strut. And we can see I've got drive axles going to this, so this must be a front wheel drive car. Here's our sway bar. Now this rack and pinion is our steering gear. And on the back here, and I've got a closer picture on the next slide, you are going to turn the shaft. The steering column is going to connect into your pinion gear. And so as you're turning your steering column, your pinion gear is turning. And this long tube here has a rack gear. So you can think of a gear that has internal teeth and cut open and laid out. And I'll show you here in a moment. And so on each side, these tie rods are going to move in and out, and they'll move in and out together, right? So not one side's not just going to move. If that happens, and something's gone horribly wrong. So as my rack gear moves, my wheels are going to get turned in one direction or the other direction. Here's another picture of that design. So here is our pinion gear. It's sort of a sort of round gear. Most of the time, it's going to be a helical cut type of gear. And the flat gear is a rack gear. So it's pretty much a flat piece of metal that has teeth on it. And as I turn my pinion, it's going to it's going to sort of move my rack gear in one direction or the other. As you can see, we've sort of taken everything from the last design with a steering gearbox and your parallelogram linkage, and we sort of put all that in one to where the gear itself does the same action as the linkage, and so that's how we got less components. Now, one thing I'd like to point out to you is that these gear teeth, you can see the gear teeth actually change angle as they go along. They get a little bit steeper and steeper. We call that sort of a variable gear or a variable steering. The variable rack here allows you to get sort of the best of both worlds when it comes to performance as well as drivability when you're driving around town and parking and things like that. Now, this is going to be part of our power steering, so I don't want to get into that quite yet. Now, from the rack, as the rack is moving back and forth, on each side, I've got tie rods. And these tie rods are going to be separated into two pieces. The inner tie rod that attaches to the rack and the outer tie rod that attaches to your steering knuckle. So, on top, you can see here, I've got an inner tie rod that attaches to the rack, an outer tie rod that attaches to the steering knuckle, and I've got a big boot. They call that a bellows boot. That's to protect your inner tie rod. If you ever have fluid leaking from a bellows boot, it's not fluid leaking from the boot because the boot's not supposed to have fluid in it. If you ever have power steering fluid leaking from these bellow boots, you have to replace the rack because it means that the rack seal is bad and they don't really make kits to repair those. So you're probably going to have to replace the entire rack and pinion gear. Now here's a closer pic. You can see our bellows boot that's going to attach to our rack gear there, and out here is sort of an arm that comes off of our steering knuckle, and this sort of ball and socket joint at the end here is going to be our outer tie rod end. Now the outer tie rod end is threaded to the inner tie rod end, and what we want to be able to do is change the length again of those tie rods to help with your wheel alignment. What we don't want are your wheels that are turning in different directions at the same time, right? We'll talk about that in the next video, but that's what we call toe. So what we want is our wheels turning perfectly straight when my steering wheel is straight. And when I turn right, both wheels will turn right. When I turn left, both wheels will turn left. So that adjustment is built into our tie rod. Now with power steering systems, we have actually different ways of doing that these days. Older designs use hydraulic pressure to assist with your steering in one direction or the other. Newer designs are using an electric motor to assist in one direction or the other. So any type of hydraulic system is going to be driven by a power steering pump that is driven off of one of the accessory belts on the engine or the serpentine belt on the engine. Now these power steering pumps are usually capable of really high pressure, like 1,000 psi. So if you are turning in your vehicle with power steering and you got that sucker cranked because you're making a U-turn and you hear a sort of hissing coming from underneath the hood every single time you do that, that's normal. That's your power steering pump maxed out. So it's probably not a good idea that while everything's running, you have your steering wheel cranked in one direction for a long period of time, because we're talking really high PSI inside of that system. Now, here's a closer look at our hydraulic power steering system in a rack and pinion design. Here is a pulley running off of the engine. Behind it is a power steering pump, and on top is your reservoir for your fluid. So power steering pumps are going to have two lines. One is going to be a pressure line, the other is going to be a return line. The pressure line is going to feed into your steering gear, whether it be a rack and pinion or gearbox, and in this case it's a rack and pinion. And inside, I think it's really important to know that the fluid never touches the gears. The fluid is not to lubricate the gears, the fluid never touches those gears. On your rack and pinion, here's our rack gear, here's our pinion gear. All the way over here, this is not the rack gear itself. It's on the same shaft, but what we have is a whole section where we're in a cylinder and I've got a piston, much like a shock absorber, that can move from side to side. And again, it's attached to that rack gear, but I do have a seal that's protecting any fluid from getting into the gear area. Now, when I want to go in one direction or the other, I've got a control valve down here that's going to determine if pressure is going to go in this side or in this side. Do we want to help our driver turn right, or do we want to help our driver turn left? Now, it'll push a piston in one direction or the other, depending on this control valve for what direction you're turning, right or left. And when, let's say I'm putting pressure on this side to turn left, then I'm going to need to relieve pressure on the left side, and that's going to go back through our return line, back to our reservoir to recirculate. Here is a recirculating ball type gearbox that has a power steering system. So we've got a pump separate from our reservoir, but we still have a pressure and return line that is going to feed again into our rotary control valve, which is going to either help turn our gear in one direction again or another. So it's the fluid never, even in this design, doesn't ever touch your gear. It's in a control valve that's going to help turn the shaft in one direction or another. Now the power steering pump itself can be of a couple different designs. I'll let a suspension class get into that. But it is a positive displacement type pump generally, which means, from, if you remember our oil pump, means it pumps the same volume every single time it rotates. So because of that, any positive displacement type pump needs to have a pressure relief valve because we don't always need 1,000 psi. Maybe I need 1,000 psi when I'm trying to crank the steering wheel in one direction or the other, but if I'm just driving straight, I don't. So we need a way to relieve all that pressure back to our reservoir. Now, a lot of manufacturers will use automatic transmission fluid as their power steering fluid. And that's totally fine, but it's always important to never assume that a manufacturer does that. Always check your fluid specifications, especially in your owner's manual. I know that Honda uses their own fluid. I believe Nissan uses ATF, so it really depends on what manufacturer and what vehicle, on what type of fluid that these systems are going to use. Now, with that being said, most designs are going to an electronic rack and pinion design or an electronic power steering design. So you don't have a power steering pump that is essentially sucking power from the engine. Power steering pump is going to act as a parasitic draw on your engine, and then you may lose or sacrifice a couple horsepower from that gear on there. So that's why a lot of people will delete that or disconnect it. But an electronic rack and pinion doesn't have that. So you don't have the drain on the engine like the hydraulic design does. And it uses an electric motor that's either going to be on the rack itself or it's going to be on the shaft or steering column to help turn the steering in one direction or another. Now, here's one of the coolest parts about this design. On a hydraulic power steering design, the engine needs to be running for you to get power steering, right? As soon as you turn the engine off, it's really hard to turn your steering wheel. Well, on an electronic rack and pinion, all you need to do is key on. Engine doesn't have to be on, and all you need is that electric motor to get voltage to turn from one direction into another with assistance. So that's really cool, and that's also another reason why a lot of manufacturers went to it, because a lot of your hybrid vehicles and electric vehicles use this design. I did embed a video into your canvas for some better visuals on your electronic rack and pinion designs. Now, the last thing I want to talk about in this section is going to be your four-wheel steering. Not all vehicles have four-wheel steering, and I'll talk about the pros and the cons here in a minute. But four-wheel steering means that our rear wheels are going to turn as well as our front wheels. Our front wheels are always going to be our main turning wheels. However, on a four-wheel design, the rear wheels will turn. They just won't turn as much as your front wheels, because if they did, the car would be very hard to handle. Now, these designs can either be mechanical, hydraulic, or electric in nature. Obviously, electrics has so many benefits, especially in a four-wheel design, because on a mechanical or a hydraulic design, I'm going to have either a linkage or I'm going to have hydraulic lines that have to run from the front of the vehicle to the back of the vehicle. It's a lot of extra components. It's a lot of extra movement, a lot of extra things to wear out. So the electric design, again, is sort of superior there. And your designs are going to have two phases or one of two phases. Not all of them have both. And we call this either opposite phase or same phase. And I gave you guys pictures with opposite phase and same phase. Opposite phase steering is going to be used at low speeds. And if you've ever looked at or watched monster truck shows, they use an opposite phase four-wheel steer. So the rear wheels are actually going to turn in the opposite direction. So you can see over here, our front wheels are turning left and our rear wheels are actually slightly turning right. Why would you want to do that? It's actually going to help extremely help actually to make really sharp turns. If you have an opposite phase vehicle, or I'm sorry, an opposite phase four-wheel steering vehicle, you can make new U-turns like you wouldn't believe. If you've, a better way to think of this is if you've ever seen the really long fire trucks where they are so long that they actually have to have another person steering in the rear. That's how they're doing it. And when they need to make really tight turns, the person in the rear will turn in the opposite direction as the person in the front, so that vehicle is able to make a really, really tight turn. Now, you don't want that at high speeds, because if I want to go make a lane change, I'm going to go across the whole darn freeway if I don't spin out, because of the rear wheels moving in the opposite direction. So when you go to a higher speed, what you want is same phase. Same phase is where my front wheels are turning left and my rear wheels are slightly turning left. This is going to help you make really nice and easy lane changes at really high speeds. But is not going to work necessarily near as good at low speeds. And your opposite phase sucks at high speeds, but works really well at low speeds. So like I said, some manufacturer designs utilize both opposite phase and same phase, especially with an electric design. But some manufacturers may only utilize one. Like I believe Chevy utilized a design in their Silverados where they only had opposite phase at low speeds, and then obviously just wouldn't go in high at high speeds. And some vehicle manufacturers made designs where they only used same phase at high speeds and it was disabled at low speeds. So it really depends from manufacturer to manufacturer. Now here's why you might want it or not want it. The advantages is you get a lot more responsive cornering behavior and stability. The response is just unexplainable. You kind of have to experience it yourself. But it is so much more responsive that some drivers don't like it. Some drivers feel that it's too responsive and they feel out of control of the vehicle. So it really takes some getting used to, but I think once you get used to it, you start to really like it because of that responsiveness. So that's going to be it for our steering video. It's not a very complicated system. So if you have any questions at all, please, again, leave something in the comments for me or send me a message on Canvas, and I will see you guys in the wheel alignment video.